The water was still rising when they found it. Dawn, April 19th, 1943, in the shallows off Rendova Island in the Solomon Chain. Lieutenant Commander Takeshi Miyamoto stood knee-deep in warm seawater, staring at what remained of an American patrol torpedo boat wedged between two coral outcroppings. The hull was cracked open like an eggshell, its bow pointed skyward at an absurd angle, but it hadn't burned. That was the strange part. Most vessels hit by Japanese destroyer fire disintegrated into burning wreckage. This one had simply stopped, as if it had decided to rest rather than die. Around him, salvage crews from the Imperial Japanese Navy vaded through the debris field, their white uniforms already stained brown with coral dust and oil. They had been sent from Rabaul with explicit orders: examine any captured American equipment, catalogue every detail, and report anything that might explain why these small boats kept escaping destruction. For months, PT boats had been harassing Japanese supply convoys in the Solomons, striking at night, vanishing before dawn, ghosts made of speed and darkness. Tokyo wanted answers. Miyamoto approached the wreck slowly, his boots squelching in the sand. The boat was smaller than he expected, barely 80 feet long, narrow as a racing shell. Its profile was sleek, almost delicate, with a graceful curve to the deck that reminded him of a samurai's blade. But what struck him most was the surface. He reached out and touched the hull just above the waterline. It was smooth, impossibly smooth, like polished wood rather than welded steel. He knocked against it with his knuckles. The sound that came back was dull, resonant, organic. He turned to his assistant, Ensign Nakamura, a young engineer fresh from the Naval Academy at Etajima. "This is not metal," Miyamoto said quietly. Nakamura frowned and tapped the hull himself. His eyes widened. "Plywood," he whispered. Miyamoto said nothing. He simply stared at the wreck, feeling the weight of disbelief settle over him like a fog. Behind them, the salvage team began unloading equipment from their landing barge: acetylene torches, block and tackle, canvas tarps. The plan was to dismantle the PT boat piece by piece and transport the fragments back to Rabaul for analysis. But already, even before they had cut a single seam, something felt wrong. This boat had survived a direct hit from a destroyer's deck gun, the kind of impact that would have shredded a steel hull. Yet here it was, broken but intact, its wooden skin holding together as if stitched by invisible thread. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Miyamoto climbed onto the slanted deck, his hands gripping the wet wood for balance. The surface was textured, not painted smooth like Japanese naval vessels, but layered, as if built from sheets glued together under pressure. He could see the grain of the wood beneath the faded grey paint, swirling patterns like fingerprints. Amidships, he found the remains of the engine compartment. 3 massive Packard engines, each one the size of a small automobile, sat tilted at grotesque angles. Their cooling jackets were cracked, their manifolds torn apart by the explosion that had finally stopped the boat. But even in ruin, they radiated power. Miyamoto knelt beside one and examined the cylinder heads. 12 cylinders, arranged in a V, each bore polished to a mirror finish. These were not military engines in the traditional sense. They were racing engines, built for speed above all else. Nakamura appeared at his side, holding a clipboard already damp with spray. "Sir," he said, "the engines are American automotive design, Packard Model 4 M2500, supercharged. Estimated output, 1,500 horsepower each." Miyamoto did the arithmetic in his head. 3 engines, 4,500 horsepower total, driving a hull that weighed perhaps 40 tons fully loaded. He stood and walked aft, where the torpedo tubes had been mounted. Only one tube remained, the others torn away in the fighting. It was a simple design, a steel cradle that held a marked-up torpedo, launched by compressed air and gravity. No complex hydraulics, no electrical firing systems. Just a lever and a prayer. Around the tube, he noticed something peculiar. The wooden deck had been reinforced with thin steel plates, but only in critical areas, around the engines, beneath the torpedo tubes, near the fuel tanks. Everywhere else, it was just wood, laminated and smooth, bearing the scars of salt and violence. The Americans had saved weight wherever they could, stripping away every ounce that didn't contribute to speed. It was a philosophy Miyamoto recognized from his own training. In naval architecture, every decision was a fin-diff, compromise between protection and performance. The PT boat had chosen performance and accepted the consequences. By midday, the salvage team had rigged cables around the wreck and begun the slow process of lifting it free from the coral. As the hull emerged from the water, streaming seawater and trailing strands of kelp, its construction became clearer. The outer skin was mahogany, thin as paper, backed by layers of lighter wood, and bonded together with some kind of adhesive that refused to separate even under the stress of the crash. Miyamoto ordered a section of the hull cut away for closer inspection. When the torch finally burned through, the smell that rose from the cut was sharp and chemical, like varnish mixed with something medicinal. The layers inside formed a cross-hatched pattern, each ply oriented at a different angle, creating a lattice of strength. It was laminated monocoque construction, the same technique used in aircraft fuselages, but applied to a boat. Nakamura ran, his hand over the exposed cross-section. "The glue," he murmured. "It's harder than the wood itself." Miyamoto nodded. He had seen this before, years ago, in a lecture on British aircraft design. The enemy had developed synthetic resins, waterproof adhesives that cured under heat and pressure, turning multiple sheets of weak wood into a single composite, stronger than most metals. The PT boat wasn't built like a traditional vessel, planked and framed. It was molded, like a sculpture, its hull shaped in two mirror halves and then bonded into a seamless whole. That night, Miyamoto sat alone in his tent on the beach, writing his preliminary report by lamplight. He chose his words carefully. The recovered patrol torpedo boat represents a significant departure from conventional naval construction. Its hull is composed entirely of laminated wood, bonded with advanced synthetic adhesive. Preliminary assessment suggests the design prioritizes speed and maneuverability over armor or firepower. Estimated top speed exceeds 40 knots, possibly higher. Then he added a line that he knew would raise eyebrows in Tokyo. The vessel's construction is crude by our standards, yet effective. It embodies a philosophy we may have underestimated, that simplicity and speed can compensate for lack of sophistication. He folded the report and sealed it in an envelope. Tomorrow, it would be flown to Rabaul, and from there to naval headquarters. But even as he prepared to sleep, Miyamoto couldn't shake the image of that smooth wooden hull lying broken in the shallows, faster in death than most ships were in life. In the spring of 1943, the Solomon Islands had become a graveyard of ambitions. Japanese forces, stretched thin across thousands of miles of ocean, clung to their forward bases with increasing desperation. Supply convoys, once routine, had turned into nightly gambles against American air power and the shadowy menace of patrol torpedo boats. These PT boats, as the Americans called them, were a new kind of enemy, fast, elusive, and maddeningly effective. They struck at night, launched torpedoes from point-blank range, and vanished before Japanese destroyers could respond. For the Imperial Navy, accustomed to decisive fleet actions and gunfire duels, the PT boats were an insult, mosquitoes that refused to be swatted. Tokyo's Naval General Staff had received scattered reports about these vessels, but details were sparse. Survivors spoke of high-pitched engine roars, of sudden explosions in the darkness, of shapes that moved faster than any boat had a right to move. Intelligence analysts suspected the boats were lightly armed and poorly protected, opportunists rather than warriors. But the losses kept mounting. Transports sunk, supply runs delayed, morale eroding with each failed convoy. The High Command wanted answers. What made these boats so difficult to stop? How did wooden hulls survive the punishment of open ocean warfare? And most troubling of all, Why couldn't Japan's own torpedo boats, built of steel and armed with superior torpedoes, achieve the same results? Miyamoto understood the unspoken pressure behind his assignment. Japan's naval doctrine had been forged in the age of battleships, when tonnage and armor defined power. Speed was important, but only in service of bringing guns to bear. The idea that a small, unarmored boat could dominate sea lanes violated every principle he had been taught, yet the evidence was undeniable. In the 6 months since the PT boats had arrived in the Solomons, they had become the most feared element of the American naval presence, not for their firepower, but for their unpredictability. The salvaged PT boat represented a rare opportunity. Most enemy vessels, when destroyed, sank or burned beyond recognition. This one had been forced ashore by 2, damaged and then abandoned by its crew. It was intact enough to study, broken enough to dissect. Miyamoto's orders were explicit: determine the design principles, identify weaknesses, and recommend countermeasures. But as he stood on the beach that first morning, watching the wreck emerge from the water, he suspected the real lesson would be more uncomfortable than Tokyo anticipated. Japan's own torpedo boats, the Type A and Type D designs, were formidable by any standard. Built of welded steel, armed with powerful oxygen torpedoes, and crewed by elite sailors, they embodied the Navy's commitment to quality and craftsmanship. Each boat was a small masterpiece of engineering, its hull plates fitted with precision, its engines tuned by mechanics who had spent years learning their trade. But they were slow by PT boat standards, topping out at 33 knots under ideal conditions. And they were heavy, their steel hulls and armoured bridges adding weight that robbed them of agility. In night battles, where seconds meant survival, that difference was fatal. Miyamoto had read after-action reports from destroyer captains who had engaged PT boats. The accounts were frustratingly similar. Radar would detect a target at close range, moving at high speed. Guns would open fire, tracers arcing into the darkness. Then nothing. The target would vanish, either behind a smoke screen or into the cover of nearby islands. By the time illumination rounds lit up the sea, the PT boat was gone, leaving only a fading wake. Japanese boats trying to pursue found themselves outrun, their engines straining at full throttle while the enemy pulled away effortlessly. The mystery was not just speed, but endurance. PT boats operated far from their bases, running night after night without apparent fatigue. Japanese intelligence estimated they burned enormous amounts of fuel, yet they never seemed to run dry. Their engines, pushed to limits that would destroy conventional marine diesels somehow, held together. And their crews, often young men with little naval experience, handled them with a confidence that bordered on recklessness. It was as if the boats themselves encouraged aggression, rewarding audacity with survival. Back in Tokyo, engineers had begun drafting plans for a new generation of fast attack craft. The designs incorporated lessons from early encounters: more power, lighter construction, better maneuverability. But without understanding how the Americans had achieved their results, the plans remained theoretical. Every improvement came with a cost. More powerful engines required more fuel, which added weight. Lighter hulls meant less protection, which increased vulnerability. The arithmetic was unforgiving. Japan's industrial base, already stretched by the demands of war, could not afford to waste resources on failed experiments. That was why the salvaged PT boat mattered. It was a blueprint, a window into enemy thinking. Miyamoto knew that his report would be scrutinized by admirals and engineers, by strategists and industrialists. If he could decode the philosophy behind the design, Japan might find a way to counter it, or better yet, copy it. But as he examined the wreck over the following days, he began to suspect that copying would not be enough. The PT boat was not simply a clever design, it was the product of a different worldview, one that valued improvisation over tradition, speed over strength, and practicality over pride. On the third day of the salvage operation, Miyamoto ordered the engines removed for detailed inspection. It took 6 men and a portable crane to lift each Packard motor free from its mounts. As the first engine swung clear of the hull, dripping oil and seawater, Miyamoto circled it slowly, notebook in hand. The castings were rough, almost crude, with visible tooling marks and unfinished surfaces. In a Japanese factory, such work would have been rejected as substandard. Yet the engine had run for hundreds of hours, delivering power that would have torn apart a more delicate design. He knelt beside the crankcase and examined the main bearings. They were oversized, designed to handle stresses far beyond normal marine use. The connecting rods were forged rather than machined, trading elegance for durability. Every component told the same story. This was not a precision instrument. It was a workhorse, built to survive abuse and keep running. The Americans had sacrificed refinement for reliability, and in doing so they had created something Japan's meticulous engineers had never imagined, an engine that thrived on punishment. Nakamura, watching from nearby, shook his head. "It's so wasteful," he said. "Look at the size of these cooling jackets. They could have saved 10 kilograms per engine with better design." Miyamoto stood and brushed the rust from his hands. 10 kilograms, he agreed. But how many hours of engineering time? How many skilled machinists? Quickly, by workers who didn't need a decade of training. That's the real innovation. The realization hung in the air between them. Japan's strength had always been its craftsmanship, the tradition of the master and the apprentice, the belief that perfection was achieved through patience and discipline. But perfection took time, and time was the one resource the war would not grant. The PT boat, with its rough edges and pragmatic choices, had been designed for a world where speed of production mattered more than beauty of execution. As the sun set over Rendova, casting long shadows across the beach, Miyamoto stood beside the disassembled wreck and felt the weight of understanding settle on his shoulders. The Americans had not simply built a faster boat, they had built a faster way of thinking. And that, he knew, would be far harder to defeat than any weapon. By the 5th day of examination, the salvage team had transformed the beach into an outdoor laboratory. Components from the PT boat lay arranged in careful rows on canvas tarps, each piece tagged and numbered. The hull sections, cut into manageable panels, revealed their internal structure under the harsh tropical sun. Miyamoto moved among the fragments like a surgeon studying a dissected body, searching for the hidden principles that had given the vessel its impossible speed. What troubled him most was not the wood itself, but how the wood had been used. Japanese boat builders had worked with timber for centuries, crafting everything from fishing vessels to warships with a mastery that bordered on art. But this was different. The PT boat's hull was not shaped by hand or fitted by eye. It was engineered, manufactured, assembled according to a logic that had more in common with aircraft construction than traditional naval architecture. He called Nakamura over and pointed to one of the hull panels. "Look at the layering," he said. "The grain alternates at 90 degrees with each ply. Why?" Nakamura studied the cross-section, running his finger along the exposed edges. "But with alternating layers, any crack would be stopped by the cross-grain." "Correct," Miyamoto said. "Now look at the thickness. 3 plies of mahogany on the outer skin, then a core of lighter wood, then more mahogany on the inside. It creates a sandwich structure, stiff on the outside, flexible in the middle. The entire hull can absorb impacts without fracturing. It's the same principle used in aircraft stressed skin design. The adhesive that bonded these layers together remained a mystery. Chemical tests, conducted with portable field equipment, suggested it was a phenolic resin similar to bakelite, but modified for marine use. Under magnification, the glue lines appeared almost crystalline, as if the resin had fused the wood fibers at a molecular level. Miyamoto tried to separate two, bonded plies with a chisel and a hammer. The wood splintered, but the glue held. He tried again with a hacksaw, cutting through one of the samples. The blade passed through the wood easily, but bogged down in the adhesive layers, which were harder than the surrounding material. "This is not shipbuilding," Miyamoto muttered. "This is chemistry pretending to be carpentry." He made detailed notes, sketching the laminate structure and recording measurements. The outer skin was only 3/8 of an inch thick, less than a centimetre, yet it had withstood the violence of combat and the punishment of tropical seas. By comparison, Japanese torpedo boats used steel plate 5 millimeters thick for their hulls, 4 times heavier for roughly the same strength. The weight savings were extraordinary. A steel hull for a boat this size would weigh over 6 tons. The wooden hull weighed barely 2. But weight was only part of the equation. As Miyamoto examined the hull's shape, he began to appreciate the sophistication hidden beneath the rough construction. The bottom was nearly flat, rising only slightly toward the bow, designed to plane across the water rather than cut through it. The chines, the sharp angles where the bottom met the sides, were hard and pronounced, creating lift at speed and helping the boat rise onto its own bow wave. The stern was squared off, almost brutally so, allowing the propellers to sit as close to the surface as possible without losing grip. It was a racing hull, pure and simple. Every line, every curve optimized for one purpose: to go fast. Armor, seaworthiness, crew comfort, all had been sacrificed to that single goal. In calm waters, the design would be devastating. In heavy seas, it would be a nightmare, pounding through waves with bone-jarring violence, soaking the crew with spray, demanding constant attention at the helm. But in the confined waters of the Solomon Islands, where engagements happened at night in relatively sheltered channels, it was perfect. Miyamoto walked to the stern and examined the propeller shafts. They were bronze, polished smooth, angled downward at 15 degrees to improve thrust efficiency. The propellers themselves had been salvaged separately, 3-bladed designs with aggressive pitch meant to bite into the water and claw the boat forward. Each propeller was over 2 feet in diameter, large enough to harness the massive power of the Packard engines, yet small enough to avoid cavitation at high RPM. The transmission system was equally revealing. Instead of heavy marine gearboxes, the PT boat used automotive transmissions, modified units from trucks or buses, lighter and simpler than anything Japan's naval suppliers would have approved. The Americans had raided their own civilian industry, pulling components from mass production lines and adapting them for war. It was pragmatic, almost improvisational, and it had worked. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Nakamura approached with a new discovery, a section of the boat's electrical system. The wiring was color-coded, red for positive, black for negative, with printed tags at every junction. The circuit breakers were automotive-style fuses, cheap and replaceable, rather than the expensive marine switches used in Japanese vessels. Even the instrument panel, recovered from the wreckage, showed the same philosophy. The gauges were simple, easy to read, mass-produced. There was no elegance, no pride of craftsmanship, just function. "Sir?" Nakamura said, holding up a bundle of wires. "Every component here is off the shelf. Nothing custom-made. They've built a warship using parts from cars and trucks." Miyamoto took the wires and examined them. "That's exactly the point," he said. "They didn't need custom parts. They needed parts they could replace anywhere, anytime. If this boat limped back to base with a blown fuse or a broken gauge, any mechanic with a toolbox could fix it in an hour." He thought of Japan's torpedo boats, with their bespoke components and specialized tools, waiting weeks for replacement parts that had to be machined by hand in naval workshops. The Americans had designed for repairability, for endurance in the field, for a kind of warfare where logistics mattered as much as firepower. It was a lesson Japan had learned too late in too many campaigns. As the sun climbed toward noon, the heat became oppressive. Miyamoto retreated to the shade of a palm tree and reviewed his notes. The picture emerging from the wreckage was both impressive and troubling. The PT boat was fast, yes, but its speed came from a constellation of choices, each one individually modest, but collectively revolutionary. Lightweight construction, powerful engines, hydrodynamic efficiency, simplified systems, all working together in a design that prioritized one thing above all else: getting in, hitting hard, and getting out before the enemy could respond. That evening, as the salvage team packed up for the day, Miyamoto stood at the water's edge and watched the tide roll in. The remains of the PT boat, now reduced to scattered fragments and measured diagrams, would be loaded onto a barge tomorrow and shipped to Rabaul. From there, his report would travel to Tokyo, where engineers and admirals would dissect his findings and debate their implications. But he already knew what they would conclude. Japan could not build boats like this, not at scale, not in time. The industrial infrastructure didn't exist. The adhesives were unavailable. The engines, those magnificent Packard motors, represented a level of automotive engineering Japan's manufacturers had never attempted. And even if they could copy the design, they couldn't copy the philosophy behind it. The willingness to use rough components, to trust mass production over handcrafting, to value speed of construction over perfection of execution, all of that ran counter to everything the Imperial Navy believed. Miyamoto pulled out his notebook and wrote a single sentence at the bottom of the day's observations. The Americans have built a weapon we cannot replicate because they have accepted compromises we cannot stomach. He closed the notebook and walked back toward the camp, leaving the wreckage behind. A wooden ghost testifying to a kind of warfare Japan had never imagined. The report reached Tokyo 3 weeks later, carried by diplomatic pouch through the long chain of supply that stretched from Rabaul to Truk to the home islands. It arrived at the Naval Technical Bureau on a grey afternoon in May, where it joined a mountain of similar documents, damage assessments, intelligence summaries, requests for materials that no longer existed. But Miyamoto's report carried a weight that bureaucrats recognized immediately. Within hours, it was on the desk of Rear Admiral Fukuda Keiji, the officer responsible for fast attack craft development. Fukuda read it twice, slowly, his face revealing nothing. Then he called a meeting. The room that gathered 2 days later was small, deliberately so. Present were representatives from the Naval General Staff, the Technical Bureau, and 3 senior engineers from the Yokosuka Naval Arsenal. No stenographers, no formal minutes. What they were about to discuss bordered on heresy. Fukuda began by reading selected passages from Miyamoto's report aloud. His voice was flat, clinical, letting the words speak for themselves. When he reached the section describing the plywood construction and synthetic adhesives, one of the older engineers, a man named Saito who had designed destroyers before the war, interrupted. "This cannot be accurate," Saito said. "Plywood cannot withstand the stresses of combat. The report must be flawed." Fukuda looked at him calmly. "Lieutenant Commander Miyamoto is one of our best analysts. He studied at MIT before the war. He knows the difference between plywood and structural composite." Saito shifted uncomfortably but said nothing more. Fukuda continued reading. When he finished, silence filled the room like water filling a sinking ship. Finally, one of the staff officers spoke. "If the Americans can build boats like this, fast enough to evade our destroyers, using materials we considered obsolete, what does that say about our own designs?" No one wanted to answer. The question hung there, accusatory and inescapable. Japan's torpedo boats, the pride of the Navy's fast attack doctrine, suddenly seemed artifacts from another era, beautiful, sophisticated, and irrelevant. Another engineer, younger than Saito, leaned forward. "Can we replicate this design?" he asked. Fukuda shook his head. "Not in any meaningful time frame. We don't have access to the adhesives they use. Our chemical industry is focused on explosives and synthetic fuel. We don't have enough high-performance aviation engines to spare for boats, and even if we had the materials, our shipyards are not set up for this kind of construction. We build with steel, with rivets and welds. This requires furniture, factories, and autoclaves." Then Saito, his pride wounded but his mind sharp, asked the question everyone was thinking. "If we cannot build them, can we at least counter them?" Fukuda opened a folder and pulled out a second document, a tactical analysis compiled by destroyer captains who had engaged PT boats in the Solomons. The conclusions were grim. Traditional gunnery was ineffective against such fast, small targets, especially at night. Radar could detect them, but by the time guns were laid and fired, the boats had moved. Searchlights made the destroyers into targets themselves. The only reliable defense was air cover, and air cover was a luxury Japan could rarely afford in contested waters. One possibility, Fukuda said, is to develop our own high-speed interceptors, smaller, faster boats designed specifically to hunt PT boats. But that brings us back to the same problem. Speed requires power. Power requires fuel. And fuel is something we do not have in abundance. The mathematics of the Pacific War were becoming cruelly clear. Every gallon of gasoline, every ton of steel, every engineer's hour had to be allocated among 1,000 competing needs. Aircraft, tanks, cargo ships, submarines, all screaming for resources. Fast attack boats, no matter how effective, would have to wait in line. The meeting ended without resolution. Fukuda ordered copies of Miyamoto's report, distributed to relevant departments, with instructions to explore any feasible adaptations. But everyone in the room understood the truth. Japan would not build PT boats. It was already too late. As the officers filed out, Saito lingered. He approached Fukuda and spoke quietly, almost in a whisper. "We've been outthought, haven't we? Not just outbuilt, outthought." Fukuda looked at him for a long moment. "Yes," he said. "And that's far worse." Across the Pacific, in a cluttered office at the Elko Naval Division in Bayonne, New Jersey, a very different conversation was taking place. Engineers gathered around blueprints for the next generation of PT boats, the Mark 15 model, incorporating lessons from combat reports flooding back from the Solomons. The atmosphere was casual, almost chaotic. Men in shirt sleeves argued over propeller pitch and fuel capacity, sketching modifications on napkins, debating the merits of one engine configuration over another. There was no reverence here, no tradition weighing down innovation. If something worked, it stayed. If it didn't, it was changed by Friday. The chief designer, a man named Sutphen, stood at a drafting table covered with photographs of battle damage. He pointed to one image, showing a PT boat, with half its stern blown away, still afloat. "See this?" he said. "That boat made it home." The crew patched the hole with canvas and kept going. "That's what we're designing for. Not elegance, not to win awards. We're designing for the 18-year-old kid who has to fix it in the dark with a wrench and a prayer." Someone asked about weight savings in the new design. Sutphen shrugged. "Shave off anything that doesn't make it faster or keep it floating. If it's not an engine, a gun, or a torpedo tube, it's negotiable. Armor, forget it. These boats survive by not getting hit." That was the philosophy in 4 sentences. It would have horrified Miyamoto, and yet he would have understood it perfectly. The Americans had accepted the logic of expendability. PT boats were not meant to last years. They were meant to last long enough to do their job. If they survived 100 missions, wonderful. If they survived 10, that was enough. They could be replaced. Back in the Solomons, the war ground forward. Japanese supply convoys continued their desperate runs, and PT boats continued to hunt them. On the night of August 1st, 1943, a division of PT boats intercepted a Japanese destroyer column off Kolombangara. Among them was PT Sto Dziewięć, commanded by a young lieutenant named John Kennedy. The encounter would become famous for different reasons, but the tactical reality was identical to dozens of other engagements. Fast boats darting through darkness, torpedoes launched at close range, the roar of engines and the chatter of machine guns, and then silence as the boats vanished into the night. Kennedy's boat was rammed and sunk, cut in half by a destroyer that never saw it coming until impact. The crew survived by clinging to the wreckage, that durable plywood hull that refused to sink even when broken in two. They swam to a nearby island and were eventually rescued. The hull, shattered and waterlogged, drifted for days before washing ashore, another piece of evidence for Japanese salvage teams to puzzle over. By late 1943, the pattern had become undeniable. PT boats were not winning the war, but they were making it unwinnable for Japan. Every convoy harassed, every transport delayed, every destroyer forced to waste ammunition chasing shadows, all of it contributed to the slow strangulation of Japanese logistics. The boats themselves were almost irrelevant. What mattered was the disruption they caused, the uncertainty they created, the psychological weight of knowing that nowhere was safe. Miyamoto, still stationed at Rabaul, watched the war's trajectory with a growing sense of futility. His report had been acknowledged, filed, and essentially ignored. The Navy had no capacity to implement his recommendations. Instead, resources were poured into larger projects, super battleships, advanced submarines, kamikaze aircraft, weapons of desperation dressed up as innovation. The lesson of the PT boat, that simplicity and speed could matter more than size and sophistication, was lost in the noise of a losing war. In his private journal, he wrote an entry that would only be discovered decades later. "We are fighting the wrong war with the wrong tools." The Americans understand something we do not, that war is not about beauty or honor or craftsmanship. It is about logistics, about the ruthless application of enough force, fast enough, cheap enough, to overwhelm any defense. They have turned manufacturing into a weapon, and we have no counter for it. Our ships are works of art. Theirs are products, and products can be made by the thousands. By 1944, American PT boats had evolved again. New models featured improved radar, more powerful engines, and refined hull designs. They operated not just as raiders, but as scouts, rescue vessels, and gunboats, filling roles the Navy had never imagined when the first boats were commissioned. Their wooden hulls, once considered a weakness, had proven remarkably durable. Salt water didn't corrode them. Battle damage could be repaired with carpenter's tools, and when a boat was finally too damaged to save, it could be stripped for parts, and its engines installed in a newer hull within days. The Japanese response, when it finally came, was too little and too late. In early 1945, the Navy began experimenting with fast attack boats powered by aircraft engines, desperate attempts to match the PT boat's speed. But the programs were starved for resources, fuel was scarce, skilled labor was gone, and the strategic situation had deteriorated so badly that fast attack boats, even if they had worked, would have made no difference. The war had moved beyond them. Fukuda, the admiral who had read Miyamoto's report with such attention, committed suicide in August 1945, one day after the Emperor's surrender broadcast. In his final letter, he apologized for failing to prepare the Navy for the kind of war it actually had to fight. Among his personal papers was a copy of Miyamoto's report, heavily annotated in the margins. One note, written in red ink beside the description of the plywood hull, simply, read, "We should have listened." Miyamoto survived the war. He was repatriated to Japan in 1946, emaciated and sick with malaria, but alive. He found work with a civilian engineering firm, helping to rebuild Japan's shattered industry. He never spoke publicly about the PT boat or his role in analyzing it, but in private, with trusted colleagues, he would occasionally reference it as the moment he understood that Japan had lost not just a battle of ships or men, but a battle of philosophies. In 1952, during a visit to the United States as part of a trade delegation, Miyamoto toured the Elko plant in New Jersey. The factory had been converted to civilian production, building pleasure boats and small yachts, but the bones of its wartime operation were still visible. He walked the assembly floor, now quiet and orderly, and imagined it as it must have been during the war, roaring with activity, turning out PT boats like newspapers rolling off a press. His American hosts, unaware of his wartime role, proudly showed him photographs of PT boats in action. One image caught his attention, a boat at full speed, its bow lifted clear of the water, spray cascading from its chines. It looked impossibly fast, impossibly fragile, and impossibly free. He stared at it for a long time. When his translator asked if something was wrong, Miyamoto simply shook his head and smiled. "No," he said. "Nothing is wrong. I was just remembering something." What he remembered was the morning on Rendova, standing beside the salvaged wreck, touching that smooth wooden hull and feeling the future under his fingers. He had known then, even if he couldn't admit it, that he was witnessing the death of one era and the birth of another. The age of battleships and armor and craftsmanship was ending. The age of speed and mass production and expendability was beginning. The PT boat, crude and effective and utterly modern, was its prophet. The legacy of those wooden boats extended far, beyond their tactical impact. After the war, the design principles they embodied, lightweight construction, powerful engines, modular systems, shaped everything from racing yachts to commercial speedboats. Fiberglass, the material that would eventually replace plywood in boat building, was a direct descendant of the laminated composite hull. The idea that civilians could build weapons, that furniture factories could become arsenals, influenced Cold War manufacturing strategies on both sides of the Iron Curtain. In Japan, the lessons were harder won but no less significant. The post-war economic miracle that transformed the nation from ruins to industrial powerhouse was built, in part, on the realization that mass production and standardization were not enemies of quality, but enablers of it. The same engineers who had once insisted on handcrafted perfection learned to embrace automation and efficiency. They studied American methods, including the automotive techniques that had powered the PT boat's engines, and adapted them to Japanese culture. The result was a manufacturing revolution that would eventually challenge American dominance in automobiles and electronics. But the human cost of that education was never forgotten. Miyamoto, in his later years, became a quiet advocate for pragmatic engineering. He taught at Tokyo University, where he emphasized adaptability over rigidity, function over form. His students never knew about the salvaged PT boat or the report that went unheeded. They only knew him as a professor who insisted that the best design was the one that worked, not the one that impressed. He died in 1978, at the age of 69, respected but not famous. His obituary mentioned his wartime service only in passing, but among his personal effects, his family found the journal he had kept during those years. The entry from Rendova, written by lamplight in a tent on the beach, remained as vivid as the day he wrote it. "This boat is faster than our ships because it cares nothing for our rules. It is a machine built by men who understood that survival matters more than pride. We called it primitive. It called us slow. History will judge which of us was right." History did judge. The PT boat, wooden and imperfect, outlasted the steel giants that hunted it, not because it was better in any absolute sense, but because it was better suited to the war it had to fight. It was simple when complexity meant vulnerability. In a conflict where industrial capacity determined victory, the PT boat proved that sometimes the best weapon is the one you can build in overwhelming numbers, even if each individual example is flawed. Today, a handful of PT boats survive in museums, their wooden hulls carefully preserved, their Packard engines silent. Visitors walk past them without fully understanding what they represent. They see vintage warships, relics of a distant conflict. They don't see the revolution those boats embodied, the moment when American pragmatism collided with Axis perfectionism and proved that good enough, multiplied by 1,000, beats perfect every time. Miyamoto would have appreciated the irony. He spent his life building things that were meant to last, designing with precision and care. But the boat that taught him the most important lesson of his career was designed to be disposable, built quickly, used hard, and replaced without sentiment. It was the opposite of everything he had been trained to value, and it worked precisely because of that. In the end, the plywood hull was stronger than steel, not because of its material properties, but because of what it represented, a willingness to accept imperfection in service of a greater goal. The story of the PT boat is not really about boats at all. It's about the choices nations make under pressure, the philosophies they embrace or abandon, the compromises they accept or reject. Japan chose craftsmanship and lost. America chose production and won. The lesson cost thousands of lives and years of suffering. But it echoed through the decades that followed, shaping how the world thinks about manufacturing, design, and the nature of technological progress. Standing on that beach in 1943, Miyamoto could not have known any of this. He only knew that the wreck before him violated every principle he had been taught, and yet it worked. That contradiction, that uncomfortable truth, was the real discovery. Not the glue, or the engines, or the hydrodynamic design, but the idea behind them, that breaking rules can be its own kind of wisdom, and that sometimes the most sophisticated response is the simplest one. The sun set over Rendova for the last time on his assignment. Water's edge one final time and looked out at the darkening sea. Somewhere out there, more PT boats were preparing for another night's hunt. And somewhere in Japan, engineers were still designing perfect ships that would arrive too late to matter. He turned away and walked back toward the camp, leaving the beach empty except for the tide and the memories of a wooden boat that had been faster than anyone expected, more durable than anyone believed, and more important than anyone understood until it was already too late. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.